This video is presented to you by the Group 2. This video will give you more knowledge about what Copernican revolution is and who are the scientists involved in this revolution.
What does our solar system really look like? If we were to somehow fly ourselves above the plane where the sun and the planets are, what would we see in the center of the solar system? The answer took a while for astronomers to figure out, leading to a debate between what is known as the geocentric or the Earth-centered model and the heliocentric or the sun-centered model. Galileo Galilei, year 1564 to 1642, made such significant contributions to human understanding of the cosmos and the Earth's place in it that he often receives credit for heliocentrism. Galileo's main contributions to the revolution were observational data, which he obtained with a telescope he built himself. He was the first astronomer to scan the heavens with a light magnifying instrument and is sometimes referred to as the father of observational astronomy. He published his observations, and they were so significant that the Catholic Church tried him as a heretic and confined him to house arrest for the rest of his life. What Galileo actually did was provide observational support for a theory that had been put forward by Polish astronomer Nicolaus Copernicus, year 1473 to 1543, who died 20 years before Galileo was born. Copernicus completed his treatise just before he died, and it was banned by the Catholic Church. But nevertheless, it spawned a movement that eventually resulted in the adoption of the heliocentric model. The movement became known as the Copernican Revolution, and it lasted for about 100 years. The Church was a powerful conservative institution, and its influence was felt throughout Europe. It had subscribed to the view that the Earth was the center of the universe since its foundation, and it didn't want to change. Anyone who challenged the view was subject to torture and execution. By the early 16th century, Copernicus summarized his ideas in a short treatise titled Commentarius, or the Little Commentary. This 40-page manuscript described his ideas about the heliocentric hypothesis, which was based on 7 general principles. These principles stated that
there is no one center of the universe. The Earth's center is not the center of the universe. The center of the universe is near the sun. The distance from the Earth into the Sun is imperceptible compared to the distance to the stars. The rotation of the Earth accounts for the apparent daily rotation of the stars. The apparent annual cycle of movements of the Sun is caused by the Earth revolving around it. The apparent retrograde motion of the planet is caused by the motion of the Earth from which one observes. As already noted, Copernicus was not the first to advocate a heliocentric view of the universe, and his model was based on the work of several previous astronomers. The first recorded examples of this are traced to classical antiquity, when Aristarchus of Samos published writings that contained references which were cited by his contemporaries such as Archimedes. Now that you are aware that universe is a name given by most astronomers to the sphere, whose center is the center of the Earth, and whose radius is equal to the straight line between the center of the Sun and center of the Earth. This is the common account as you have heard from astronomers, but Aristarchus of Samos brought out a book consisting of some hypotheses in which the premises led to the result that the universe is many times greater than so-called. His hypotheses are that the fixed stars and the sun remain unmoved, that the earth revolves about the sun in the circumference of a circle, the sun lying in the middle of the orbit, and that the sphere of the fixed stars, situated about the same center as the sun, is so great that the circle in which he supposes the earth to revolve bears such a proportion to the distance of the fixed stars as the center of the sphere bears to its surface.
Believe it or not, a mere 500 years ago, nearly everyone believed that the heavens rotated around the earth in a geocentric model rather than the universe revolving around the sun. There are also non-Earth-centered models which had been proposed around the same time, such as the Philolaus central fire model, which postulated all of the bodies in the universe revolved around a central fire. But the fire isn't the sun. Scientists had also figured out that the Earth must rotate to account for the fact that the stars move around us. Fortunately, these ideas caved to Aristotle's theories, where he provides three common sense arguments against a non-Earth-centered model. These arguments are: if the Earth was spinning, why don't objects fly off the Earth? If the Earth was moving around the sun, why does it not leave flying birds behind? And finally, if the Earth was in orbit around the sun, why don't we see a parallax effect in the stars?
Johannes Kepler, 1571 to 1630, is responsible for creating Kepler's law of planetary motion. These laws include that the orbit of every planet is an ellipse with the Sun at one of the two foci, that a line joining a planet and the Sun sweeps out equal areas during equal intervals of time, and that the square of the orbital period of a planet is directly proportional to the cube of a semi-major axis of its orbit. Kepler was one of the first to incorporate the field of physics and the field of astronomy. This caused some controversy, however, his ideas became more widely read and accepted after his death.
Isaac Newton. He was a well-known English physicist and mathematician who was known for his book Philosophiae Naturalis Principia Mathematica. He was the main figure in the scientific revolution for his laws of motion and universal gravitation. The laws of Newton are said to be the ending point of the Copernican revolution. Newton used Kepler's laws, planetary motion, to derive his law of universal gravitation. Newton's law of universal gravitation was the first law he developed and proposed in his book Principia. The law states that any two objects exert a gravitational force of attraction on each other. The magnitude of the force is proportional to the product of the gravitational masses of the objects and inversely proportional to the square of the distance between them. Along with Newton's law of universal gravitation, the Principia also presents his three laws of motions. Tycho Brahe. He was a Danish nobleman who was well known as an astronomer in his time. Further advancement in the understanding of the cosmos would require new, more accurate observations than those that Nicholas Copernicus relied on, and Tycho made great strides in this area. Tycho Brahe accepted Copernicus' model but reasserted geocentricity. In 1572, Tycho Brahe observed a new star in the constellation Cassiopeia. For 18 months, it shone brightly in the sky with no visible parallax, indicating it was a part of the heavenly region of stars according to Aristotle's model. However, according to the model, no change could take place in the heavens, so Tycho's observations was a major discredit to Aristotle's theories. In 1577, Tycho observed a great comet in the sky based on his parallax observations. The comet passed through the region of the planets. According to Aristotelian theory, only uniform circular motion on solid spheres existed in this region, making it impossible for a comet to enter this region. Tycho concluded that there were no such spheres, raising the question of what kept a planet in orbit.